Yeah, I think pilot tests are essential if you're doing street lighting conversion in any urban environment with any complexity at all. I mean, if it's very simple and straightforward, maybe not. But it really you're going to learn things. You don't want to install thousands of fixtures and find out some unforeseen thing arose. And in dense urban environments, especially in your residential areas, how the fixture performs and everything, how it distributes light is really critical. You can't goof up. You really got to know what you're going to be doing. And you're right, 4000 K has sort of become the standard. And as you know, the higher the color temperature or the cooler the light, the higher the efficacy, the more lumens per watt, the more efficient it is. So that's the first thing that has to be taken into consideration. So if that wasn't an issue, what would the color temperature want to be? Well, and so what we learned is that when you put in, for example, if you put in 4000 K street lighting, and you're comparing it to very, very warm high pressure sodium, which is typical, legacy street lighting, it looks very different and very cool. But when you compare that 4000 K to 6000 K LED, it actually looks warmer. So it's really hard to answer this question. Now, I think one reason you might use, a warmer color temperature for, aesthetic reasons would be in your period decorative fixtures, where there's sort of a feel, and this is all just subjective, aesthetic opinion, but it's kind of like people sort of expect that to be more like a gas flame or a old incandescent light bulb or a candle. I've heard anecdotally people perceive the higher color temperature fixtures as more glary. But the problem is the LED fixtures themselves have a different sort of glare profile, I guess, which is hard to, it's been interesting to sort out just observationally. But some people perceive them as very glary. And I'm not sure if it's the color temperature or just the fact that the LED fixture is, emitting the light in a different way than a conventional HID fixture. So spectral tuning and the idea that you could change the color temperature over the course of the evening is a very intriguing idea, and it's becoming, the technology exists to do it, but you have to think about what you're doing, because a white LED is inherently has blue light in it, regardless of its color temperature. So if your objective for doing spectral tuning is to reduce the amount of blue wavelengths, then you're really going to need to do something beyond just white light LED tuning, which is what we're seeing in indoor products. And that's becoming a technology that's available to us for interior lighting. So that's a very interesting topic that I think that's the next sort of generation of street lighting, is figuring out how to do, and I think spectral tuning maybe isn't the right phrase, because to us lighting designers, when you say spectral tuning, we call it tunable white or whatever. This is a little more complicated, because what you want to do is be able to reduce the short wavelength light and maybe sacrifice some color rendition. My feeling is that you probably, in most cases, are going to be able to reduce the amount of light, reduce your light levels below what they should be, but reduce the amount of light in the city, because if you do it right, in the process of converting all your fixtures, you're going to get rid of a lot of probably overlighting. The tendency has been to overlight our cities. So we can, if we do it now, so worst case is you don't do that, you don't even get that benefit. So you're doing what I call a one-for-one replacement. If you've got a high pressure sodium fixture that puts out so much light, you get an LED fixture that puts out the same amount of light for less energy, and so your amount of your sky glow is going to be the same. Actually, your sky glow then is going to be way worse because because you got the blue wavelengths. So what you want to do is generate less light to start, but even if you do that, because of the multiple, for sky glow multiple on the short wavelengths, you could actually end up with more sky glow. And this is my concern with the conversion that's going on. The energy efficiency benefits and everything are fantastic and well worth it, and it's a huge environmental benefit. But possibly we're getting that big benefit, but we may actually be, if you consider sky glow an environmental damage, doing more environmental damage and making that problem worse, which would be really unfortunate. So there is some evidence that either the higher color temperature or just the higher color rendition improves visibility. It's a very complicated problem. I think a lot more research still needs to be done on it. My own experience, there seems to be something going on there, that it seems brighter under the, just comparing 4000K LED streetlights to high pressure sodium, equal lumens. You light the street, you're a city, you light the street, you own it, you're kind of taking responsibility for that, and so you better do it right. And part of right means lighting it to defensible standards, so in terms of light levels, basically. So if there's an accident and a bicyclist gets hit or somebody trips on the sidewalk, and they might want to claim that, in our lawsuit-friendly world, that it was a fault of the lighting, and the city needs to be able to fall back on something and say, no, the street was lighted properly. So with that said, that means that it doesn't really matter what I think or what you think about perception of perceived brightness under different color temperatures, whatever. It matters what the standards allow us to do. Is that, and when you're lighting streets in a dense urban environment, street lighting is actually a misnomer. Well, it's definitely not roadway lighting. It really is, it's sidewalk lighting. Because you don't really need to light. You need to light for the pedestrian visibility, maybe, but at low vehicle speeds, headlights should be sufficient for that. So, but you still need to light the sidewalk because people expect the sidewalk to be lighted. And what happens is, this is where RP8, the IS standard, may evolve, I hope, because there is sidewalk criteria in RP8. Most people don't apply it, but it tends to be a controlling factor. So basically, if you light the sidewalks to meet the criteria, you're probably going to meet the roadway criteria too. The message is that the lighting a street out in the suburbs, like where there's no sidewalks or something, is a completely different lighting problem than lighting a street in the middle of the city with sidewalks right up to the curb and high pedestrian activity. We need to get away from this sort of one-size-fits-all approach to street lighting. And I would like to see that happen where maybe manufacturers, start producing products that are a little more tuned to some of the less forgiving conditions where you have houses right up against the sidewalk, things like that. The other obvious advantage is light pollution reduction, and it's a pretty easy way to if you do a setback of reduce your light levels in half, which at late at night, which is allowed by the standard, because effectively what you're doing is reclassifying the street or reclassifying the pedestrian activity. So you're basically going to a lower pedestrian activity. You're picking a time, whether it's 10 o'clock or 8 o'clock or midnight or whatever, and cutting your light levels in half, which is defensible by the standard. So that's cutting your light pollution in half, just like that, which is a great thing. And I think that's a really nifty environmental benefit that maybe people don't think about. When people think about adaptive control, they think about energy savings, maintenance, the reporting. So the fixtures all tell you what they're going to do. And but I think that additional benefit is sort of underappreciated. I mean, what I've learned is this huge unrecognized benefit, to me at least, which is the future adaptability of the system. So we can change the light levels. A city that puts in adaptive controls can change the light levels anytime they want. So if the standards, if RP8 comes out and says, hey, you don't need this much light, maybe because of spectral effects, or maybe because of new studies on detection distances, I don't know. Then, boom, we can adjust it down and achieve and then we get the energy savings benefit. If you don't put in a dimming system, now this assumes, now we say adaptive control, I mean this is adaptive controls, I mean it means that you can adjust the light level, not just turn the fixture on and off. If you don't put that in, or at least the capability to put that in, then you never, that's it. And most, LED installations are going in there and they're putting those fixtures in. And we know this, we're pretty confident now, the failure rates are very low from what I hear, that what the manufacturers are promising for lifetimes on these things is probably going to pan out, that these things are going to be out there on the poles they're going to be out there on the poles until something significantly more efficient comes along. We expect that the output of the LEDs will gradually drop over time, and there's predictive data on that. But with adaptive dimming, you start out with the fixture dimmed down to 70%, with the idea that you can ramp it up over time. So you'll be using a little more energy as you go, but you're not using it the whole lifetime of the fixture. So there's some energy savings there too. Yeah. This is another interesting thing about adaptive controls that I think people would be concerned about doing late night setback, because they go, oh my God, cut the light levels in half. There'll be an uproar. There'll be riots in the street. There'll be crime rates will go up. What we found is that nobody notices. If you can get the utility to accept your control system reporting as metering, and you're doing a late night setback, and even if you're not doing that setback till midnight, halfway through the night, and say you're doing a 50% setback, that's 25% energy savings. So you're going to cut your electricity costs of street lighting by 25%. I mean, that's not bad.